All right, so before we go into the next section, just a quick review on chapter 1-4 with solving the absolute value functions. Just don't forget that you have to look at the two cases that are possible. Here's a few more notes. If you would like to write those into your notebook, just pause and you can copy these as you need. All right, so going into chapter 1-5. So chapter 1-5 is all about solving inequalities. And so if you'll remember, looking back, one-step inequalities meant that you had to look at any two numbers like A and B, and you'll have just one of the following situations. It will be true. Either A is less than B, A is equal to B, or A is greater than B. So for any numbers, this will always hold true. So now, if we're multiplying or dividing, this is one of the properties of inequality that we are going to have to deal with. So let's say, for example, that number A is greater than the number B. Then if you multiply any number to both sides, you'll have kind of the opposite effect happening, where when C is negative. So just remember, if you multiply the left side by a negative number, as well as the right, so if C is negative, what it automatically does, it'll flip the inequality symbol. So let's look at an example when we have like negative 21 less than negative 14. Well, obviously that's a true case, right? Because negative 21 is smaller than negative 14. But if we divide both sides by negative 7, then what we end up with is 21 divided by 7 is 3, but look what happens. You have to flip that sign around. So see how it started this way, now it's facing this way. Immediately whenever you divide by a negative, you got to flip that sign. So the rules are here that you need to follow. And then if there's a certain way of expressing an answer when you're dealing with inequalities, and you can write it in this manner. This is how you read this. It's the brackets kind of start your notation off by stating that y, all the y's, and this bar you can say such that. So the solution is all the y's such that y is less than 9. So now let's look at your packet section 1-5, solving inequalities. You'll see some of the same things that I've already mentioned, and they give you some sample problems to look at. And so here, if they want you to graph a particular inequality, then go ahead and go through the same steps, and here's an example of how. And then until you reach the inequality which you're looking for. So y is greater than negative 5. So in that case, if I wanted to graph that, what I could do is I could draw a little number line, and this is 0 here. Sorry about this. This should have been a straight line right here. So if I'm looking for negative 5, all I need to do is 1, 2, 3, 4, 5. You identify the number that you're looking for, which is a negative 5, and then you look at this, the inequality symbol. If there was a little equal sign underneath it, then you would say it's equal to negative 5. But in this case, it's greater than. So all you do is identify the negative 5 with like a donut, make sure there's a donut hole, and then all the numbers that are greater than negative 5 come this way. So you're going to have to shade in this section right on the line all the way up. It doesn't matter how long you go. Some people will take it all the way up to the arrow, but then you would draw your line this way because you want the numbers that are bigger, greater than negative 5, which happen to be this way. So you'll have some more examples, and it explains a little bit more here how a circle means that the point is not included. But if you have like a line like you do here, then you would make it a dot, like an actual colored line. Because if the solution is all p's such that p is greater than or equal to negative 40, then if it is equal, then you do shade it in. So you have some more examples here for you to work on your own. So let's look at the study guide and intervention section. You have a few more notes, things that I had already mentioned in my notes. And so you have some examples and then of course the problems to work. So let's go ahead and look at any one of these. So let's just do number 5. Let's solve it first for B and then we can graph. So sorry about that. So remember, anytime you have a number outside of the parentheses, don't forget to distribute inside. So this ends up as 4 times B is 4B. 4 times -7 is -28, plus 6 is less than 22. So let's continue solving this. Here I end up with numbers that I can already subtract from each other since one's negative, one's positive, or add them. And so we have -28 plus 6. So I'm just going to write it down here for lack of space. So I have 4B minus 22 is less than 22. And so I can move this over. You can treat the inequality like an equal. This becomes a plus 22. So then I have now 4B is equal to, it's less than, not equal, less than 22 plus 22 is 44. And so I could just simply divide both sides by 4. So B is less than 11. So now I have to identify the 11. Then I have to figure, do I color it or not? Well, there is no bar here. There's no equal sign. So it's open. And I'm looking for any number that is smaller than 11. Well, the numbers smaller than 11 come this way. So you would just do something like that. Then if you continue looking at your problems, you kind of the same thing continues. Let's just do another inequality here and see what we need to do. So for example, for question letter C, number 1, using the C's, I don't want that 3 down here, so I multiply both sides by 3. So that gives me 3C is greater than or equal to C plus 4. So whatever it is that's down here being divided, just multiply it to both sides and it'll get rid of it. Then I can move the C over here. So I get 3C minus C is greater than or equal to 4. So therefore 2C is greater than or equal to 4 because 3C minus C is 2C. And you divide both sides by 2. So I get C is greater than or equal to 2. So I identify my 2. I do have that equal sign, so then it is equal, it can be equal to 2, or number C greater than 2, so anything greater than 2 comes this way. There you have it. And then of course you have more practice problems to do to see what you need to work with. Let me see if I can find one that has a negative to demonstrate that. So I found question number 3. Let's go ahead and work on that. So the R is fine on this side, but I need to get this -16 to come this way. So I turn it into a positive 16. Now I have -8R greater than or equal to 16. Now to solve for R, I just divide both sides by -8. Check this out. I just divided by a negative. Remember that rule? What happens to this is you flip it around. So instead of greater than, now I'm going to have less than. So these cancel. R is less than or equal to, and it is a positive divided by a negative, so I get a -2. So I look for my -2. It has a line, so I color it. And all the R's that are less than -2 go this way, so I shade that area over here.